Hello YouTube viewers, welcome back to my channel. I'm Tips. Today what we're going to do is demonstrate how to extract the silver from those solutions that I had left over from my $11,000 gold bar refining. First thing I need to do is add some more sterling silver to those solutions in order to consume any free nitric that still exists out there. So that's what we're going to do. We're going to heat the solutions up, and then I'm going to put some additional 925 sterling silver items in those jars to consume the excess nitric. Now, just to show you what I've got coming up in the future, I've still got the stock pot solution here. This is palladium in solution that's full of ammonium chloride, ready to be bubbled with chlorine gas. And then we'll get the palladium out of this solution. That video's coming up. Also, I have some hard disk drive platters here from laptop PC computers scrapped out. And I've got the platters here. We're going to grind these up in a blender and see if we can extract some precious metals out of these hard disk drive platters. It's coming up in a future video. Finally, last but not least, I've got some of these melt drop computer scrap bars from eBay. The folks take these, melt the scrap into a bar like this, and it looks like they buffed it up and cleaned it up with a wire wheel real good to make it nice and shiny and look like there's gold in there. But what I'm going to do is take a couple of these bars and try to extract any gold that we can get out of them in a future video. So those videos are coming up in the future. But right now, what we're going to do is demonstrate how to get the silver out of those solutions from my previous gold refining video right now. You'll recall in my previous video that I alloyed sterling silver with the carat scrap to reduce the gold content of the carat scrap. With the gold content lowered, I could then add hot dilute nitric acid and dissolve out all of the silver and all of the base metals. Each of these hot dilute nitric acid treatments extracted silver and base metals and some platinum group metals from the carat gold. I poured off these solutions into 3 separate containers and saved these solutions so that we could extract the silver and other precious metals from the solutions. And that's what we're going to do right now. We're going to show how to get the silver and other precious metals out of these solutions that I saved from the previous video. Here's our 3 silver jars from my previous refining video, and these will be the subject of this video. But before I start on the silver, I've got a little experiment running over here. I've got some 50-50 dilute nitric acid in this beaker here. Got it heated up. It's at 90.4 Celsius, 194.5 Fahrenheit. And I just wanted to demonstrate why it's important to add silver to the gold before we try to remove the base metals and silver out of our gold. This is my wedding band. It's made out of 14K gold. And what I'm going to do is I'm going to drop it into this hot dilute nitric acid and watch what happens. As you can see, there's absolutely no reaction. It just sits there untouched by that hot dilute nitric acid. My wetting band has been sitting in that hot dilute nitric acid now for about 3 or 4 minutes. And as you can see, it's completely untouched by that hot dilute nitric acid. I'm going to put it in some distilled water here to cool it off. Set it off to the side. And what I have over here, just to show you the difference, this is a silver chain, 925 sterling silver chain. I'm going to put that in the acid now and watch what happens here. I get an immediate boiling reaction as the nitric acid dissolves that silver. Alright, this chain is completely dissolved. It only took about 60 seconds. But the point of this experiment is to show that dilute hot nitric acid won't touch 14K gold. But if I add silver to that 14K gold, get the gold content down around 25%, then the hot dilute nitric acid can penetrate in and remove all of the silver and all of the base metals out of this 14K gold alloy. Here's my wetting band. I've rinsed it off real good with some just regular tap water, but you can see there's just a little bit of etching going on the outside surface there, but that'll all buff out real easily. I'll be able to restore this to perfect condition. So the nitric acid had zero, or not zero, but very little effect on that 14K gold. Here I'm burning some 10K gold, and I'll add it to this beaker marked 10K. I've got some 14K gold that I'm going to burn and put in the beaker marked 14K. And then once we get this burned, I'm going to add some hydrochloric acid to both of these samples, and then I'll carefully measure out some concentrated nitric acid, add it to both of the beakers with the 10K and the 14K gold in there. When we add that nitric acid, it'll form Aqua regia, and we're going to try to dissolve this karat gold without inquarting. We're going to go straight to Aqua regia and see what kind of result we get. One of the questions in the comments section from my 11K gold, $11,000 gold refining was, why don't you just put the karat gold and dissolve it right in Aqua regia? Why do you add silver? And so what we're going to do here is we're going to demonstrate what happens if we try to dissolve the karat gold in Aqua regia. I've got these beakers on medium heat in Aqua regia, and now we're just going to let these things go. We'll check on them in a little bit, see what kind of result we get. Alright, while we're waiting for the reaction to happen back there, I'm going to take one of my silver jars here. It's full of silver, undissolved, which tells me that my nitric acid is completely consumed in this jar. So what I'm going to do is I'm going to filter it now, and we'll show you how to get the silver out of this solution. Alright, I've got nearly all of this solution in the filter now, and I just wanted to show you down in here. This is all the silver that solution was sitting in. This silver will consume any excess nitric that was in this solution. So now what I'm going to do is I'm going to take this solution here, and pour it into my, see if I can make some room here so you can see what I'm doing. I'm going to pour this solution that's going to have nitric acid still in it from the gold refining process. I'm going to pour that into the silver in this empty jar. And again, what I'm doing here is I'm transferring the solution out of this jar that I'm picking up into this jar that has silver in it. Okay, I don't want to overfill this jar here because the silver in there is going to react with the nitric and I don't want it to overflow. Now what I'll do is I'll put this up on the heat over here and we'll start gently heating that to get the rest of the silver to go in the solution and to consume the excess nitric acid that's in that solution. Now I'm going to pour this solution in here and combine these two, and that'll free up one of my jars for any further gold refining that I want to use it for. I'm just going to transfer this into this jar so I got it all in one place. We're starting to react here in the silver jar. The excess nitric is being consumed by that silver that was in there. Over here you look at the refining experiment with the Aqua regia directly on the karat gold, and it's been boiling in there now for about half an hour. If you notice here, one solution is black and the other one looks green. This is why we don't try to dissolve the gold directly in Aqua regia. It's best to add silver to that gold and quart it, and then treat it with dilute nitric acid to remove all those base metals and silver before we put it in the Aqua regia. Both of those solutions look dirty, and it's going to be very difficult to try to get the pure gold out of both of those solutions. Here's our filter. It's going to have precious metals in it, so I'll save that. Here's our solution, nice and clear. Up here, I've got the silver there in that other nitric solution. Getting some fumes, that's indicating that the silver is going into solution. Over here, I've got my two gold experiments going. I'm going to shut the heat off on that now, and we'll go from here. Our silver solution back here has been on for about 6 hours now, maybe a little longer, on medium heat, and I've pretty much got everything in there. Well, there's still some solids in there, which is a pretty good indication that I've got all the nitric out of this solution. So I can pull this off and let this cool off now. That's what I'll do. These two gold solutions, this one don't look too bad, but you can see there's still some metal in there that's not dissolved. If you can see that on the camera there, it's right black looking. It does not look good. I'll finish this up at a later date. Here's the 10K. Got a real dirty solution, and I only did this to demonstrate what not to do here. Trying to dissolve this stuff, this karat scrap, straight in Aqua regia produces two dirty solutions. I've got some passivation going on in there. I'll deal with this later. Right now I'm going to concentrate on getting the silver. This is a copper line set for an air conditioning unit. I bought it for $100, and what I'll do here is cut some pieces off of the copper tubing there and flatten them out, and we'll use the copper to cement the silver out of those solutions. Here we go. We're going to take some silver here that I have filtered, silver solution. I'm going to add some copper to this beaker up here. 4 pieces of copper. We're going to put in about 1.5 liters of distilled water here. And then I'm going to add some of the silver solution out of this flask, and we'll get the silver to come out of solution. Okay, I'm going to take some of our filtered silver nitrate solution here and slowly add it to the beaker with the copper and distilled water. And what will happen here is, in accordance with the reactivity series of metals, the copper and the silver will trade places in this solution. The copper will come out of solution, or the silver will come out of solution onto the copper, and the copper will go into solution. It's a pretty neat reaction to watch. The silver begins to form immediately on there. You can see the silver coming out of solution on that copper. Any platinum group metals that are in the solution will also cement out onto the copper. Here's a 5-minute segment of video speeded up 4 times. You can see the silver coming out of solution onto the copper. In order for this reaction to happen properly, a little bit of free nitric has to be present in that solution. But we don't want too much free nitric acid available, because then what will happen is the silver will dissolve just as fast as it comes out of solution. And since copper is soluble in nitric acid, we would needlessly consume excess copper in this reaction. So that's why it's important in the previous steps to consume most of the nitric acid with silver. What I'll do is this jar back here that's on the heat, when it cools down, I'll filter it, get the clear solution, set up another jar like this, add copper to it, and get all the silver and precious metals out of this one. And then I'll add some silver to this one, do the same thing, until I've got all 3 of these solutions filtered, cleaned up, cleared out, and cementing out on copper. Let me put the rest of this solution in here now that we filtered out earlier. Our silver has been cementing out on the copper now for about a half an hour. That is how we get the silver out of those solutions. And once I get it all cemented out of that solution on the copper, I'll gather that silver powder up, rinse it off, melt it up, and form some granules, and then we'll run it through the silver cell. Okay, as far as the gold back here, what I'm going to do is filter all the solids out, get everything into a filter paper, precipitate the gold out of the solution, add that to the other solids in the filter paper. So I got all the gold in a filter paper. And then I'll melt it up into a button. We'll then quart it with silver and refine the gold as usual. This is not the way to go here. I've got real dirty solutions, and this is an example of what not to do when you're refining gold. You don't want to put it straight in aqua regia and try to dissolve that gold. It makes dirty solutions and presents all kinds of problems. Well, as you can see, none of the silver will be wasted. I'll recover every bit of it by cementing the silver out of those solutions onto the copper, and then I'll recover the cemented silver. We'll rinse it out real good, melt it up into some granules, and then I'll run it through my electrolytic silver cell and make some pure silver crystal. This will conclude the video. Thanks for watching.